All right, picture this. You're a first-year medical intern. The fluorescent hospital lights are blindingly bright, casting these stark shadows across the pediatric emergency bay. The air in the room is just incredibly thick with tension, right? And it's cut only by the rapid, frantic beeping of a heart monitor. Before you is a fragile infant, struggling for every single breath. You're standing there, trying to remember your training, trying to synthesize hundreds of textbook pages in a matter of seconds. But man, the adrenaline is loud. I mean, this is the ultimate high-stakes environment. But what if, in that exact moment of absolute chaos, you had a co-pilot? Well, today in this explainer, we're looking at the fascinating source code and the clinical reality of MedAI version 8.0, otherwise known as Da Vinci. We're going to step right into the shoes of that intern and see exactly how this open-source medical AI system is fundamentally changing the game for both patient care and medical education.
Okay, let's dive into this scenario. You're the intern, and you're staring at these rapidly dropping vitals. The chest X-ray comes back showing hyperinflation and peribronchial thickening. The blood oxygen saturation, the SpO2, is hovering dangerously low at 88%. Internally, your mind is just racing. Is it asthma? Is it pneumonia? Is it something worse? The panic is definitely starting to set in. But then, you look over at the attending physician. And the crazy thing is, they aren't panicking at all. They're perfectly calm, just looking down at a sleek tablet running the Da Vinci system.
Section 1. Urgence pédiatrique en direct, the high-stakes clinical reality.
In literally a fraction of a second, human intuition meets raw processing power. Instantly, the tablet screen flashes the stark warning. You see, the Da Vinci system has an incredibly robust, localized engine. In the source material, we see that if this exact scenario were unfolding in a hospital in Paris, the system's translation layer instantly outputs critique, urgence pédiatrique, without skipping a beat. It completely bypasses any cognitive load for the doctor by immediately flagging the maximum severity of the infant's condition, right in their native language. There is absolutely no ambiguity here.
And this right here brilliantly illustrates the gap between a human in training and a specialized AI. On the left, we've got our intern's mental checklist, scattered, stressed out, trying to connect all these disparate symptoms under immense pressure. But on the right, we have Da Vinci's output. In mere milliseconds, the system synthesizes the hyperinflation on the X-ray, the low oxygen, and the pediatric profile to deliver a highly confident diagnosis: severe RSV bronchiolitis, with a whopping 98% confidence score. It just totally cuts through the noise.
But here's the best part. Da Vinci doesn't just, hand the attending a diagnosis and clock out. It immediately dictates the emergency pediatric protocol. Check out these steps: nasal suction plus oxygen, continuous SpO2 monitoring, and a direct mandate for neonatal intensive care unit admission right now. It gives the medical team an instant, actionable, step-by-step game plan, literally transforming a moment of potential hesitation into immediate life-saving action.
Section 2. Le moteur Da Vinci. Let's look under the hood of the ultimate medical AI. To generate a custom treatment plan with 98% confidence in milliseconds, that requires some seriously impressive architecture. And this is exactly what makes Da Vinci so incredibly fast and reliable. The system is built on a pure Rust architecture made up of over 2,500 lines of highly optimized code. Now, Rust is famous for its memory safety and its blistering speed, which is exactly what you want when a child's life is on the line, right? It's also 100% open source under the MIT license, meaning the global medical community can constantly audit and improve it. And the front end the attending is actually touching, it's powered by Svelte and TANSTACK cache for zero latency data retrieval, all version controlled by Gitoxide. It is, frankly, a masterpiece of modern software engineering.
So the absolutely crucial point here is this single number, 30. When Da Vinci gave that 98% confidence score, it wasn't just taking a wild guess. In the time it took our intern to blink, the back end cross-checked the infant's symptoms against 30 distinct global medical sources. We are talking about direct, real-time integrations with data from PubMed, the World Health Organization, the CDC, Doctors Without Borders, the NIH, and the Lancet. It is the ultimate consensus engine. Furthermore, it completely breaks down global communication barriers. Because medical emergencies don't just happen in English, do they? Da Vinci's programmed to seamlessly translate these incredibly complex medical data structures and treatment protocols into 12 different languages, including French, Chinese, Spanish, Japanese, Arabic, and Hindi. It literally democratizes access to elite medical synthesis anywhere in the world.
Section 3. L'interface ratatouille, structured clinical output.
Now, what's really interesting about this slide is what the attending physician is actually seeing. Notice the sheer minimalism of this ratatouille dashboard.
Because let's face it, when a patient is crashing, a doctor does not have time to hunt through flashy graphics or complicated drop-down menus. They need cold, hard data. Category, pediatric, condition, RSV, confidence, 98%, urgency, critical. And right down at the bottom, it's already identified Boston Children's Hospital as the best destination. It strips away all the visual noise to deliver pure, actionable clinical intelligence.
But Da Vinci goes even deeper to make sure the treatment plan is flawlessly safe. Simultaneously, the system has checked the infant's genetics, noting the newborn screening for conditions like CFTR and SMA were totally normal. It queries the drug database and flags crucial pediatric contraindications, specifically warning to avoid aspirin to prevent Rey syndrome and mandating weight-based dosing. It's synthesizing the genetics, the X-ray imaging, and the pharmacology all at the exact same time.
Section 4. L'avenir de la formation. The ultimate educational co-pilot.
Which brings us right back to our interns standing over in the corner of the emergency bay. For them, Da Vinci acts as the ultimate educational co-pilot. Think of it like a real-time, interactive medical textbook. Instead of reading about RSV in some quiet, dusty library, the intern watches a verified, source-backed clinical pathway unfold live, right on top of a real patient. They get to cross-reference their own hesitant clinical instincts against a vast, instantaneous database, essentially correcting their thought processes on the fly. It even provides logistical training, which, is a huge part of being a senior physician. The source code reveals Da Vinci queries a database of over 50 hospitals. It doesn't just say transfer the patient. It knows that Boston Children's Hospital is exactly 0.5 kilometers away and has precisely 45 beds available in their pediatrics NICU right now. It knows Great Ormond Street and the Children's Hospital of Philadelphia's capacities too. It literally teaches the intern how to navigate the healthcare system's infrastructure during a live crisis. And if that wasn't enough, it pushes the intern's medical knowledge to the absolute cutting edge of modern science. Right there in the dashboard, Da Vinci surfaces live clinical trial data relevant to the exact condition in front of them. In the specific case, it flags NCT 04567892, which is a phase 2 trial for an RSV monoclonal antibody. So the intern isn't just learning standard care, they're instantly exposed to the future of treatment, integrated seamlessly into their daily workflow.
So, the scene resolves. The attending doctor caps the tablet screen, and the NICU transfer to Boston Children's is instantly initiated. The infant gets the exact, perfect sequence of care they need without a single second of delay. And the intern? Well, the intern standing in the bay just learned a decade's worth of clinical synthesis, from imaging to pharmacology to complex hospital logistics, in roughly 30 seconds.
It really leaves us with a profound realization about the future of healthcare. Think about it. If the next generation of medical interns has the combined knowledge of the WHO, the CDC, and 28 other global sources instantly verified and structured right there in their pocket, how does the actual art of medicine evolve? When the heavy burden of rote memorization is lifted by an open-source pure Rust AI like MedAI Da Vinci, perhaps doctors can finally focus entirely on what machines absolutely can't do, the human connection. It's a fascinating paradigm shift for sure, and one that is entirely encoded into the very architecture we've explored today.